Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is here to get to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. The most recent image captured by the James Webb Telescope has sparked concern among scientists. Questions arise about the true nature of the enigmatic disk surrounding the nearby star Formalhut. A troubling new image displays ambiguous thickening within the disk. Formalhut, among Earth's closest and most significant stars, may differ significantly from previous assumptions. Once again, astronomers find themselves re-evaluating their understanding of star formation and the cosmos. Is it possible that we need a fundamental reassessment of exoplanet formation? The James Webb Space Telescope's remarkable capabilities have once more amazed observers. The initial public unveiling of this mysterious image of the exceptionally bright star Formalhut has prompted speculation about what lies within its vicinity. Formalhut, also recognized as the Lone Star of the South, stands as one of our nearest celestial neighbors. Recent jwst images have uncovered unexpected strictures within its surrounding disk. Peculiar dark patches and unexplained light patterns challenge existing theories about this star system. The debris disk encircling Formalhut was previously thought to indicate either potential young planets or the aftermath of catastrophic collisions. However, this new image of Formalhut, its luminous rings, and the debris disk presents a wholly different perspective, prompting new inquiries. Could these observations reveal previously unknown dynamics? Has the jwst possibly detected traces of an invisible planet navigating through this cosmic dust layer? Alternatively, are we witnessing the aftermath of a dramatic destruction spanning millennia? Scientists are now confronted with a perplexing scenario. The manner in which light behaves, refracting and reflecting within the disk, defies conventional physical expectations. These revelations not only challenge our understanding of Formalhut itself, but also call into question the fundamental principles guiding our comprehension of cosmic evolution. Did exoplanets truly form around Formalhut? NASA's designation of the enigmatic image of Formalhut within its dust shell as dusty debris has reignited vigorous debate among scientists. Formalhut is a relatively young star situated approximately 25 light-years away from Earth in the constellation of the Southern Fish. It stands out as one of the brightest stars in the night sky and was historically esteemed by the Persians as one of the four royal stars. Researchers commonly refer to the luminous disk of dust and debris surrounding Formalhut as Formalhut's belt. This region is recognized by scientists as a potential site for forming planets, which is why the JWST has directed its focus here. The James Webb Space Telescope was designed not only to reveal the universe's first and oldest galaxies, but also to significantly enhance our understanding of exoplanets. Webb's infrared spectrometer is capable of penetrating even the densest clusters of dust and gas, allowing astronomers to scrutinize mysterious gases and analyze purported objects in suspect clusters in unprecedented detail. Are these truly signs of planets? Or does this disk conceal something entirely different? Technically speaking, these disks consist of gas, dust particles, and remnants from collisions between smaller celestial bodies. Such disks, enveloping young stars, are environments where planets may either form or already exist but remain unseen. In 2008, researchers proposed the existence of Formalhut B, a potential exoplanet within Formalhut's disk. However, subsequent developments cast doubt, leaving scientists uncertain about the presence and number of planets orbiting this star. Precise spectrometer examinations of the dust and debris surrounding Formalhut not only offer precise indications of existing planets or their early developmental stages, but also provide insights into the materials composing the star's surroundings. These meticulous analyses of young star systems furnish valuable clues about the mechanisms underlying star formation and the subsequent evolution of stellar systems. Thanks to its advanced instruments and infrared observation capabilities, the JWST detects thermal emissions from the disk around Formalhut, providing astronomers with detailed analyses of the data. Each light frequency offers insights into the size, shape, composition, and other physical properties of the dust particles within the disk. Gases become visible and analyzable, gradually revealing the true nature of the activities within the disk surrounding formalhut. Previous observations have already unveiled ring-shaped strictures and gaps that suggest the presence of exoplanets. The large dust cloud within formalhut's disk was initially believed to result from collisions between substantial objects, generating significant amounts of dust. Now, emerging evidence indicates that the condensations, provisionally named F2300c and F2550w, might signify something more significant, possibly young planets. If these initial assessments prove correct in the coming months, it would mark a groundbreaking discovery, potentially revealing some of the youngest exoplanets ever observed within the rings surrounding formalhut. Detecting exoplanets amidst the vastness of space is exceptionally challenging, and observing young planets was once deemed impossible. Now, witnessing the birth and evolution of planets in other systems provides a unique opportunity to comprehend the evolution of our own solar system in an entirely new light. Formal skin, known as the mouth of the fish, formalhut is a youthful star with a significant history on Earth. In cosmic terms, it is 440 million years young and resides 25 light-years away. This spectral class, a 3V star, emits a bright white-blue hue, making formalhut one of the most familiar stars in our night sky. With a mass 1.92 times that of the Sun and luminosity 16 times greater, formalhut indisputably ranks among the brightest stars visible from Earth. In ancient times, formalhut was identified by the Greeks as part of the constellation Pisces Austrinus, which continues to symbolize the southern fish. The name formalhut originates from Arabic, derived from the term formalhut, meaning mouth of the fish. Among the ancient Persians, it was known as Han, one of the 4 royal stars revered as guardians of the heavens. In Islamic astronomy, formalhut was associated with Eldolf, the dolphin constellation, and held significant mystical and astrological importance. Arabic star names, rooted in medieval astronomy, reflect a rich tradition where stars were catalogued and named extensively, a heritage later adopted by European astronomers and still in use today. Formal skin holds a special place in indigenous cultures as well. Among some Australian Aboriginal peoples, this luminous star was viewed as a messenger of light known as the hearth. It played a central role in creation stories and was integral to their beliefs about ancestral connections. These cultural perspectives underscore the profound significance that formal skin has held in human culture for millennia. The ancient Persians, with their understanding of the stars, could hardly have imagined observing and studying distant stars as we do today, enabled by instruments such as the James Webb Space Telescope. Formalhut B, exoplanet or phantom. The question of whether and how many planets reside near formalhut remains intriguing. Despite its youth, scientists anticipate that exoplanets should already be forming in its vicinity, much like how planets in our solar system emerge from the residual dust and gas after the sun's formation. Since the 1980s, formalhut has been a focal point of intensive study, aided by increasingly advanced telescopes. In 2004, the Hubble Space Telescope's observations unveiled a sharp inner boundary within formalhut's dust disk, suggesting gravitational influence from a massive object. The disk's elliptical shape further bolstered speculation about the presence of a potential planet. As early as 2001, researchers from the University of California had postulated similar theories, although definitive evidence remained elusive at that time. In November 2008, a groundbreaking paper was published suggesting the potential existence of exoplanets within the formalhut system, backed by compelling optical evidence. By 2010, renewed attention focused on formalhut, yet new images hinted that the inclined position of its disk could have alternative explanations. Consequently, the evidence supporting exoplanet formalhut B's existence was questioned and refuted. Despite this, speculation persisted in certain circles regarding formalhut B, pondering whether it could be Earth-like. Determining the physical characteristics of formalhut B relied heavily on hypothetical orbital parameters, leading to speculative conclusions. Calculations suggested that if formalhut B were a planet, it might be roughly half to twice the size of Jupiter, with a surface temperature of -2 degrees Celsius, an indication against it being Earth-like and suggestive of a gas giant nature. Analogous to Jupiter, which could have formed as one of the earliest planets in its system, formalhut B might have contributed to a binary star system if it had more mass to potentially become a star. However, subsequent observations in the formalhut system failed to substantiate the definitive mass initially observed in the early 2000s, leading to speculation that formalhut b could instead be a transient dust cloud resulting from collisions between smaller objects. Despite efforts, the jwst's infrared detectors also failed to detect significant infrared emissions characteristic of a planet. Current consensus among scientists leans towards the idea that the object originally thought to be exoplanet formalhut b is likely a dynamically changing entity rather than a solid planetary mass. And that's it. Thanks for joining us on Spaceverse, where we delve into the mysteries of the cosmos. From the enigmatic formalhut and its elusive exoplanet to the cutting-edge observations of the JWST, we explore the evolving narratives of celestial exploration. Subscribe to stay tuned for more intriguing insights into space and beyond. Together, let's uncover the wonders of the universe.